The morning sky over the Pacific Ocean erupts in blinding white light. A wall of superheated air races across the water at nearly 300 miles per hour, slamming into the warships anchored offshore with the force of a hurricane. Massive naval vessels, each weighing thousands of tons, rock violently from side to side as if they were bathtub toys. Below deck, 169 crew members brace themselves as their ship convulses. The steel hull groans under impossible stress. Paint flakes from the bulkheads. On the surface, radar antennas snap like twigs, hurled into the sea by winds that shouldn't exist in nature. Above them, a mushroom cloud climbs toward the heavens, its cap spreading across the sky like the aftermath of nuclear war. The blast creates a crater so deep it will become a permanent lake, its waters holding secrets that will last for generations. But this is not a nuclear weapon. This is something far more audacious. As soon as nuclear weapons entered the world's arsenals, military planners faced a disturbing question. What would happen to naval vessels caught in a nuclear attack? Ships represented massive investments, billions of dollars in steel, electronics, and weaponry. More importantly, they carried thousands of sailors whose lives depended on their vessel's ability to survive. The only way to find out was to deliberately expose ships to nuclear blasts and see what happened. In 1948, the U.S. Navy conducted exactly this kind of experiment at Bikini Atoll. Operation Crossroads would be the first and last time they deliberately exposed an entire fleet to nuclear weapons, detonating 2 atomic bombs near dozens of obsolete warships to study the effects. The tests provided crucial data about what nuclear weapons could do to naval vessels. Ships close to the blasts were vaporized or sunk, while those farther away suffered damage to their superstructures and electronics. However, in the years that followed, the focus of U.S. nuclear testing changed. Nuclear weapons still seemed like strategic city busters rather than tactical battlefield weapons. It seemed relatively unlikely that enemy nukes might routinely target vessels at sea, so no serious attempt to repeat these ship survivability tests was made. But by the early 1960s, everything had changed. The Cuban Missile Crisis of 1962, which brought the superpowers to the brink of nuclear war, revealed how quickly tactical nuclear weapons could be deployed and threatened in limited conflicts, rather than just all-out strategic war. Both the US and Soviet Union were now developing tactical nuclear weapons specifically designed for battlefield use, including against naval targets. The prospect of ships facing nuclear attack had shifted from theoretical to terrifyingly real. Suddenly, the Navy realized their 1946 data was dangerously outdated. Modern thermonuclear weapons could unleash hundreds of times more power than the bombs tested at Bikini Atoll. Meanwhile, ship designs had transformed completely from the aging World War II vessels used in 1946. They now boasted new aluminum superstructures, sophisticated electronics, and advanced radar systems that had never been tested against nuclear effects. The Navy desperately needed new ship survivability data, but their timing couldn't have been worse. Just as they realized the urgent need for comprehensive nuclear tests on modern vessels, the Limited Test Ban Treaty was signed in August 1963, prohibiting atmospheric nuclear testing. The window of opportunity had slammed shut. Navy scientists found themselves facing an impossible challenge: somehow test nuclear effects on ships without actually using nuclear weapons. Toward the end of 1963, the Defense Atomic Support Agency and the Navy Bureau of Ships came up with a bold yet simple solution. If they couldn't use nuclear weapons, they would build the largest conventional explosives ever assembled: massive domes containing 500 tons of TNT each. To put this in perspective, this was considerably more explosive power than many tactical nuclear weapons, such as the Davy Crockett warhead, which had a yield equivalent to just 10 to 20 tons of TNT. But there was a crucial difference between nuclear and conventional explosives. Nuclear weapons release their energy almost instantaneously, while TNT burns much more slowly. To compensate for this, the scientists calculated that a 500-ton TNT blast would need to be detonated relatively close to the test ships to simulate the effect of a 1-kiloton nuclear weapon at a greater distance. The engineering challenges were staggering. How do you safely transport and assemble 500 tons of high explosives? The TNT would come from an unexpected source. The Naval Powder Factory in Nevada had developed a method to recycle explosive materials from old torpedoes, mines, and other obsolete weapons. over 92,000 individual TNT blocks would need to be carefully assembled into precise hemispheric domes, each standing 17 feet high and 34 feet across. The location for this unprecedented experiment, codenamed Operation Sailor Hat, was Kaho'olawe, a small Hawaiian island that had been used as a military bombing range since World War II. Remote and uninhabited, it offered the perfect combination of isolation and accessibility, far from civilian populations, but only 90 miles from Pearl Harbor Naval Shipyard. Deep waters surrounded the island, allowing ships to be positioned safely offshore while still being close enough to experience the full effects of the blast. 3 separate tests were planned, each more ambitious than the last, with ships positioned at increasingly dangerous distances from the explosions. The star of Operation Sailor Hat was USS Atlanta, a World War II light cruiser that had been dramatically transformed for this mission. Everything above her main deck had been stripped away and replaced with 2 different types of destroyer superstructures and experimental radar systems. The ship looked like a floating laboratory, bristling with antennas and instruments designed to measure exactly what would happen when 500 tons of TNT exploded nearby. On February 6, 1965, the first test, codenamed Bravo, was ready to begin. The Atlanta was positioned closest to the explosive charge, while modern destroyers like USS Cochrane and the Canadian Navy's HMCS Fraser were stationed at safer distances. Over 500 high-speed cameras were positioned to capture every millisecond of the blast's effects. Below deck, 169 Navy crew members and 60 scientific personnel waited in tense anticipation. They'd been assured the ship could survive the blast, but no one really knew what would happen. The theoretical calculations were one thing. Reality might be quite different. At 2:31 p.m. Hawaii time, the world's largest conventional explosion erupted on Kaho'olawe shore. The blast was visible from hundreds of miles away, creating a fireball that reached toward the sky and a mushroom cloud that climbed over 3,000 feet high. The explosion generated winds of 294 miles per hour and created an overpressure of 10 pounds per square inch, equivalent to a 1 megaton nuclear weapon detonating at 8,000 feet. The shockwave raced across the water at supersonic speed, slamming into the test ships with devastating force. On Atlanta, radar antennas were ripped from their mountings and hurled into the sea. The ship's tripod mast, loaded with electronics, was completely destroyed and crashed onto the deck. Aluminum structures buckled and cracked under the pressure. But remarkably, the crew below deck experienced only a shock equivalent to an Iowa-class battleship firing all 9 of its 16-inch guns simultaneously. Violent, but survivable. The ship's hull proved incredibly resilient, even when battered by flying rocks ejected from the explosion site. USS Cochrane, positioned farther away, lost power for 5 minutes as the blast wave washed over her. When power was restored, the crew found that both the 3D and 2D radar antennas had been destroyed, but the ship was otherwise intact. 2 more tests followed, Charlie in April and Delta in June, each time moving the Atlanta closer to the blast to gather more extreme data. With each explosion, the lessons became clearer. Ships could survive nuclear-scale blasts, but their electronics and superstructures were devastatingly vulnerable. The data collected from the over 500 high-speed cameras and hundreds of recording instruments transformed naval design forever. Engineers learned that antennas needed to be ruggedized, not completely redesigned. They discovered that extending superstructure sides as hull bulkheads could prevent them from being blown clean off the ship, explaining the blocky, angular appearance of many Cold War-era naval vessels. The tests also revealed the importance of protecting crews from blast effects reaching deep into ships through ventilation systems. The Navy began fitting specially shaped funnel caps and developing Citadel concepts, heavily protected control centers where ships could be operated entirely from within filtered environments. This drove the adoption of automated weapon systems and remote control guns. Most significantly, the tests proved that ships could be hardened to survive 10 pounds per square inch of overpressure without imposing unacceptable weight penalties or compromising operational capabilities. This became the new standard for naval construction, ensuring that American warships could continue fighting even after being battered by nuclear weapons. The success of Operation Sailor Hat inspired similar programs around the world. The Soviet Union conducted their own massive conventional explosions tests to study nuclear effects, while other nations incorporated the lessons learned into their ship designs. The distinctive angular superstructures and hardened electronics that became standard on military vessels throughout the Cold War all traced back to those 3 explosions on a remote Hawaiian island. The massive crater left by the final test became a permanent reminder of this extraordinary experiment, a perfectly circular lake that still holds the secrets of one of the Cold War's strangest and most successful military operations. Though the experiment had come at a hefty environmental cost, the explosions had cracked the island's freshwater aquifer, and the resulting lake became too contaminated for most marine life. There was no denying the critical military knowledge gained. The true measure of Operation Sailor Hat's success was that it achieved something many thought impossible: simulating nuclear warfare without nuclear weapons, and ensuring that American sailors would go to sea in ships designed to survive the unthinkable.